In this video, we are going to talk about absolute value transformations. So first we are going to graph a function, then we are going to transform it in terms of the absolute value, and then graph the new function to show what it would look like. So the first thing I'm going to do is graph this f of x function. I'm going to make a table of values to do that. So if I were to substitute in -2, be -2 squared minus 2 times -2 minus 3, I would have 4 plus 4 is 8 minus 3 is 5. So I'm going to do this for all the numbers. If I sub in -1, I get 0. Sub in 0, I get -3. Sub in 1, I get -4, and so on and so forth. So now if I graph this function, -2, 5, -1, 0, 0, -3, 1, -4, all right, so my second equation now, I'm going to transform it by doing the absolute value of x. So what is that going to look like? So g of x would be f of x, just every x is absolute valued. So if I substitute in -4, I get 4 squared is 16, minus 2 times 4 is -8, so 16 minus 8 is 8. 8 minus 3 is 5. Do the same thing with -3. So -3 becomes positive, squared is 9, minus 6 is 3, 3 minus 3 is 0. You're going to do these for all of that. Remember, you have to make the number positive before squaring it or multiplying it by -2. So when I plug in all the numbers, my table would look like this, and now I'm going to plot these points. And so as we can see, it's going to make a shape that looks like this. So what do we notice when we compare our blue to our red? So what I see is this portion of the blue is then reflected over the y-axis. So essentially, the positive x values of the blue are reflected over to the negative side of the x-axis. So the transformation is the results in the portion of the graph of f of x that are to the left of the y-axis are replaced by a reflection of the points or of the portion to the right of the y-axis. All right, so now, they're telling me that they're giving me the graph of g of x, and they want me to show what the absolute value of g of x would be. So essentially, I need to take what I have on the right side and reflect it over to the left. So I'm going to look for some key points. So I see this point here, reflect it. This point here, it's about there. This point here, I can reflect to there. This point here, 2.5, 6. So what's going to happen is the part that's on the left is now going to look like what's on the right. In theory, if I can draw straight lines. So that is what my, including this side too, was what my reflection or my absolute value transformation would do. It would make the graph in blue. When we do the absolute value of x, we are reflecting everything from the positive side onto the negative side. So we did the absolute value of x. Now let's do the absolute value of the entire function. So I'm going to do the same thing we did on the other side. I'm going to graph f of x by making a table. And so we can actually use the same table we had on the front page, because it's the same function. And I'm going to graph that function. And so this is what my f of x would look like. If you need to pause the video now to plot the points, go ahead. Now let's graph g of x, which is the absolute value of f. So the absolute value of f, write that in red actually, the absolute value of x squared minus 2x minus 3. So that means we're still going to substitute in the same points, just the output will become positive no matter what. So I can actually use this table to help me because I already plugged in the points. So positive 5, positive 0. Well, negative 3 become positive 3, negative 4 become positive 4, negative 3 would become positive, and then 0 and 5 would stay the same. So let's plot these points. So negative 2, 5, 0, negative 1, 0, 0, 3, 1, 4, 2, 3, 3, 0, 4, 5. So my absolute value transformation would look like this. And actually, it should probably be a little pointier here and here. All right, so what am I noticing? Now instead of reflecting over the y-axis, it's reflecting over the x-axis. So we would reflect any portion of the graph of f of x that is below so that it is above. All right, let's try this now. If we're given a graph, what is it going to look like if we were doing the absolute value of that function? So again, we said that means everything that is below the x-axis is going to reflect above the x-axis. So I see this point here. I'm going to reflect it to here. These points would stay the same. Let me pick a point down here, negative 2.5. and 6, so it's going to go up here. So now instead of being cubic, it's going to look more kind of like a ball bouncing. It's not my best graph, but that's okay. So everything that was below the x-axis needed to be reflected to be above the x-axis. So let's review. If we go back to when we are doing absolute value of the whole function, we're reflecting everything to above the x-axis.